This is an interesting one. One of the HOTS, one can get it in this particular chapter. HOTS means high order thinking skills. Let's understand the question. Let's understand the given part. Let's understand the to prove part. Moreover, I have given you the technique and I would like you to apply this particular technique. Recall all the sums which you have done in this particular chapter before attempting this particular question. Without reading the question, I would like you to look at to prove, and that's the reason I have written a different marker so that you recollect it. Recollect it. D square is BD into DC. Some early BD into EC, some early sums we have done, something of this nature. I want my children to recollect. Let's start. In the joining figure, quadrilateral DEFG is a square. Now, when I have DEFG a square, can I say multiple things? All the angles are going to be 90? Am I supposed to say that? Fine. This is 90, this is also 90. Okay, even this is 90, whatever. Either of the side I mark it out. Moreover, are the opposite sides parallel? Even GD is parallel to EF. What I want is GF parallel to D. That's the reason I have marked. Now, what I said a minute back, I want my students to refresh their concept. D square. You remember we have done something called as AC square? One AC above, one AC below. So for we to have this particular answer, what should be the CSST pattern kind be? It should be 1 DE above upon something, which is equals to something upon 1 DE. So that I can say D square is BD into EC. When I say D square, so if here there is BD, here it is EC, or vice versa. I hope my children are getting it. I hope you remember also, right? So we are looking out for that expression. We are not done. I'm saying we are looking out for that expression. Now how we can get it? It's not that easy to reach over there. Moreover, in the final stage, you might not see also those CSST very easily. So that's the reason this is a HOTS, sum which has good amount of thinking skills. We start with the very first thing. Quadrilateral DEFG is a square. Since it is proved that, I shall say proof. I shall say proof. Quadrilateral DEFG is a square. When I say DEFG is a square, what is the first thing I can say? All the sides of square are equal. So I'll mark down that all the sides of square are equal. My first point, therefore, DE is equals to EF is equals to FG is equals to GD is equals to GD. Equation number 1, reason is sides of square, and sides of square are congruent. Sides of square are congruent. We start off with our sum with the given part. DEFG is a square. Since it's a square, DE is equals to EF is equals to FG is equals to GD. Equation number 1. What next, children? You must have got it that in order to have this, it's CSST, we have to prove two triangles similar. We have to prove two triangles similar. So now we think, what are those triangles going to be? One is DE. Okay, fine, DE. But DE is not a part of any triangle. That's what the sum is all about. Next, what is BD? Okay, where is BD? BD is of this. Where is DE? That's what is of a square. And the other one is EC. EC is of this triangle. So those who want to apply slight amount of logic, from BD into EC, I just need to tell myself BD belongs to this triangle, EC belongs to this triangle. Somewhere down the line, I have to prove these two triangles similar and then work out some kind of CSST. Though it doesn't appear to be that easy, but we need to prove these two triangles similar and then work out some kind of CSST. Let me just name it from my side. Triangle 1. This is my triangle 1. This is my triangle 2. And this is my triangle 3. Let me just name it. I intend to prove triangle 2 similar to triangle 3. and then work out some kind of CSST and some kind of properties, if at all are applicable, how we'll reach to prove triangle 2 similar to triangle 3. For that, we will be proving triangle 1 similar to triangle 2. We will be proving, I'll tell you what are we going to do. We are going to prove triangle 1 similar to 2. We are going to prove triangle 1 similar to 3. And if 1 similar to 2, 1 similar to 3 is being proved, that means by the property of transitivity, can I say 2 and 3 are similar? By the property of transitivity, 2 and 3 are similar. 1 is similar to 2, 1 is similar to 3, therefore 2 and 3 are similar. That's what we are going to do. But sir, how we are going to prove 1 similar to 2? If we manage to prove 1 similar to 2, don't you think so on the same lines we can prove 1 similar to 3? So our main aim is to prove 1 similar to 2. How? Let's start. Children, when I say 1, it's all about triangle AGF. I am not starting with any kind of one-to-one correspondence, and I'll be doing it very soon. And when I say 2, it's GDB. What makes me say, or rather how we are going to prove them similar? With one-to-one correspondence, I'll start off with this. In triangle AGF, and triangle DBG. But before that, before inserting inside the triangle, I have written down something, I have shown you something. What is this signifying? GF parallel to D, property of square. With this GF parallel to D, can I say GF is parallel to BC? GF parallel to BC and AB as a transversal. AB as a transversal, can I say this angle congruent to this angle? By what? Corresponding angle theorem. By what? Corresponding angle theorem. Can you say this is parallel to this? This as a transversal. Are these two angles considered as corresponding angles? Indeed. I think so my sum is done now. Now those who are thinking that how to prove 1 similar to 2, they are in a process of getting the answer also. 1 corresponding, the other which is 90. 1 corresponding, the other which is 90. And I think so we are done with our sum. So we start with, now who parallel to whom? It is GF. GF parallel to BC and AB as transversal. AB as transversal. What? Angle. 1-to-1 correspondence is what we have to. Angle AGF. That means I have gone from 90 to that angle to F. So what should be my answer? G. Children, 1-to-1 correspondence is very, very important. D, B, G. Equation number 2 by corresponding angle theorem. By corresponding angle theorem. Now in triangle, which triangle? So since I have taken one angle which is in 1-to-1 correspondence, I can say triangle AGF and triangle DBG. AGF and DBG. Can I make very well use of AGF congruent to DBG? From where? From equation 2. The other is each is 90. So angle, once again, I've made you understand 1-to-1 correspondence. Everything is what is being told to you in this particular chapter. Now AGF, that means I want here. Now I want each is 90. I'm going from G to A to F. That means corresponding angle to 90 to nothing. So G, A, F. On the same lines, it should be corresponding angle B to 90 out there. So who is 90 over here? D. So B to D to G. B, D, G. I hope my children are understanding. Right? Here I shall say each is 90. Each is 90. Therefore, triangle AGF similar to triangle DBG by AA test. By AA test of similarity. Now those who are thinking that will I be proving, or rather will I be writing some kind of CSST? Answer is no. Why? I have told you that in which triangle am I supposed to go for CSST? Triangle 2 and triangle 3. As of now, we are talking about 1 and 2. Let this be my equation number 3. As I stated that if we prove 1 similar to 2, on the same lines we can prove 1 similar to 3. So I'm going to write down similarly. Similarly, we can prove what? Triangle AGF. Now over here also we have to be very, very precise when it comes to 1 to 1. Now when I have said AGF, A means 90. Now over here, if you are thinking that which one is going to act as a corresponding angle, then it is this angle going to be acted as a corresponding angle. Likewise here, it is there. So when I said AGF here, so it is A which is 90. So who is acting 90 over here in triangle 3? E. Then I went for something congruent, that is corresponding. Whom should I go with here? AGF. I have taken AGF with E. Then comes G. So which one now? Which one now? Should I go with F or should I go with C? Which are the two angles congruent? AGF. So who is G here? 1 to 1 correspondence to G. It is not C, it is F. So it is EFC. EFC. Check. Check. Is this F and C are 1 to 1 correspondence? Indeed. Equation number 4. AGF to DBG, AGF to EFC. Can I say from equation 4, from equation 3 and 4, from equation 3 and equation 4, we can say triangle DBG similar to triangle EFC. I shall say by property of transitivity. By property of transitivity, let me say equation number 5. Let me say equation number 5. Having proved the two triangles similar, the time has come to say CSST. Sir, what exactly we are supposed to do? What exactly we are supposed to do? I want BD EC, so I'm going to look out where BD is. BD is here. EC is here. So first, having proved, can I say therefore BD is what I wanted. BD is what I wanted. BD. Who is 1 to 1 corresponding to BD? EF. BD by EF. Then I wanted EC. So where is EC? EC is here, sir. So who is 1 to 1 correspondence to it? DG. So can I say DG by EC? Sir, BD into EC is what we can get on cross multiplying. BD into EC is what I can get in cross multiplying. Sir, your technique is going to fail? Never. Sir's technique will never fail. But sir, you only stated that there has to be one DE above, there has to be one DE below. Sir, we are not having any DE above or below. Then how? What am I not supposed to disturb? I'm not supposed to disturb BD. So I'm not disturbing BD. That's what we wanted. I'm not supposed to disturb EC. I'm not disturbing that. Still, if I say that I am right in my technique, 1 DE upper, that is above, 1 DE niche, that is below. D should be here, D should be here. Check. Check. DE and EF are equal. So can I replace this EF by D? DE and DG are equal. Can I replace this? Right? Technique is always correct. The tips given are always correct. So let me say this is equation number 6 and I shall write down CSST. I have said n number of times. Please don't write down shortcuts. From 1 and 6. I'm not going to disturb BD as it is, but instead of EF, I can write down DE. I'm not going to disturb EC, but instead of DG, I'm going to write down DE. EC. 1d above, 1d below. Cross multiply. Therefore, DE square. DE square is equals to BD into EC. So what was the thing, children? What was the thing? The thing was how to get this particular stuff. One is with a technique. Second is, it was not easy to identify which two triangles. So how did we identify it? BD, EC. BD belonging to this, EC belonging to this. So it was proving triangle similar 2 to triangle similar 3. That is, 2 should be proved similar to 3rd. And how we did that? By property of transitivity. 1 to 2, 1 to 3, therefore 2 and 3. I hope my children have understood, right?